Hello there guys, and welcome back to another epic Inexorable maths video. In this video we're taking a look at regions representing inequalities, okay? So just some notes to have a cheeky little gander at. When y is less than f of x, that represents the area below the graph y equals f of x, okay? So remember, y equals f of x, that literally just means y equals whatever you want. So it could be y equals x squared, it could be y equals x, it could be y equals 5 minus x, it could be y equals sine x, it could be y equals sine of x all squared, it could be anything you want. It's going to be a y equals, okay? And so essentially, y is less than f of x, that region on the graph literally just represents the area below the graph y equals f of x, okay? Likewise, y is greater than f of x represents the area above the graph of y equals f of x. And another thing is you need to use a dotted or dashed line for when y is less than f of x or greater than f of x, and a solid one for when y is less than or equal to f of x, or when y is greater than or equal to f of x. So if this is a sort of inequality with an equals sign sort of embedded in there, you need to use a solid line for it, okay? So here's just a quick example. This isn't an exam question. You wouldn't get this in the actual exam because I need to put my x in there, of course. You wouldn't get this in the actual exam because it's a bit too easy, but we will do it as a good warm-up because it's a nice question. So if we want to sketch the graph of y is greater than x squared, this is going to be a region, a shaded region on a graph. As always with inequalities, guys, what we like to do is essentially pretend that it's not an inequality, i.e. we're just going to say y equals x squared for now. We're going to plot that. Now you should just memorize how to plot y equals x squared. It's one of the most basic graphs that we're going to be doing in A-level maths. You just should memorize it for your own sake. It looks like this, okay? Well, not quite because I'm awful at drawing, but it looks like someone who was not good at drawing tried to draw it, and it's that, okay? That's what it looks like. A poor attempt. That's a 0, even though it looks like a sideways 6. This is the graph of y equals x squared, okay? And here's the crazy thing about it, guys. When y, and by the way, this just skims the x-axis, doesn't actually go through it, just literally touches it, tangentially tickles, as I might say, and it just goes straight back up, okay? So it looks like it's like, it looks a bit flat there, but it's supposed to just dip in and touch it, okay? So guys, here's the crazy thing. This is the graph of y equals x squared. We don't want the graph of y equals x squared. We want when y is greater than x squared. What happens, guys, when y is greater than x squared? We're above the line, as per my brilliant notes there. So guys, the region that you would shade is this one here, just like so, okay? It's this region. If you think of this as almost, I don't know, like a bowl or something, like a bowl of soup. It's the stuff that's inside the bowl of soup. It's not the stuff that's outside. If the question was y is less, let's say less than x squared, it would be everything else, okay? But there's one more thing that we must take into consideration, and that is the lines. Do we use solid or dotted lines for this question? Well, as per the notes again, we need to use a dotted line because the inequality does not actually include the function itself. And that means we cannot use a solid line because the solid line implies that it does. So just to sort of make sense of it all, there's me filling the graph back in. We're going to just replace the same line with a sort of dashed one. Exact same line, it's just dashed now. And this is the answer. This is the graph of y is strictly greater than x squared. If the question was y is greater than or equal to x squared, then yes, you would have a straight, not straight, a solid line, okay? That's supposed to just literally go straight through all of the dots. It doesn't, but it's supposed to. It'd just be a straight line. Don't put any dots for that one. So guys, that's not an actual exam question, but we will do one. And it's going to be a little bit tricky, but I think we can do it. Okay guys, so right here we've got something that might look a little bit daunting. We've got not 1, not 2, not 3, but 4 different functions. Those functions are y plus x is less than 6, y is less than 2x plus 9, y is greater than 3, and x is greater than 0. So just plotting an x and a y, and an awful, what even is that? Fish? No clue. That's a 0. Plotting our axes in, we're going to solve this thing. We're gonna plot it, okay? So how do we do it? Again, like always, we're gonna just pretend that we've got some equal signs in here. So what I'm going to do, I'll tell you what I'm gonna do first. I'm going to get it into the form y is less than f of x, y is greater than f of x, equal to or greater than, equal to or less than f of x. I want a y, some sort of inequality, and a bunch of x's. So they're all actually fine. This one you might think, hold on, that's not in the right, like that's actually fine. X is great, because that's just a straight line going up, that's fine. The problem is this one, and it's a minor problem. If y plus x is less than 6, then y is less than 6 minus x, okay? We've just taken an x away from both sides. So now we have 1, 2, 3, 4 perfectly explicitly defined functions in terms of y, except the x one, but that's fine, that's no problem, that's easy, okay? We're going to plot these graphs, but we're going to pretend that we have equal signs. So I'm going to plot the graphs y equals 6 minus x, y equals 2x plus 9, y equals 3, and x equals 0. I'm going to plot these lines, okay, and then we'll figure out what the inequalities are doing. So, without further ado, and by the way guys, if you are getting confused by the graphing parts of this, don't worry about it, because you have to remember, this is about inequalities. This is not about can you plot these straight lines, because there is an entire chapter in A-level maths about straight lines, which we will get onto in no time at all. And that is when we need to be actually plotting straight lines, knowing how to do it, gradient, y-intercept, stuff like that. We haven't studied straight lines yet. We haven't done it in these videos. So why would I expect you guys to know how to plot a straight line or something like that? So when I plot these straight lines, you might know it from GCSE. If you don't panic. We will do it later. So it's not a problem, okay? Because I always found straight lines difficult when I was in school, so I don't think it's much of an issue, okay? Everyone has their strong points and weak points. I'm going to plot them. If you think, where's he coming out with all of this stuff from? Don't worry about it. You'll get to it and we'll teach it properly soon. So, if you do know, y equals 6 minus x is a line that has a y-intercept of 6 and a gradient of -1. So it's going to look something like this. This point here is 6, this point here is 1. Or sorry, this point here is 6. Because it has a gradient of -1, okay? So it's obviously going to go through the points 6 and 6. The next one, 2x plus 9. Now the gradient 2x is a little bit steeper than the gradient x, so it's going to be a bit steeper, and it's positive because it's not negative 2x, it's positive, and it also goes through 9 as the y-intercept. Okay, so a bit not brilliant, but something like this. Yeah, not brilliant, I know. I probably should have drawn this a bit higher. So that's a straight line. There's the y, it's going to be up there now, okay? And this is the point 9, or 0, 9, you know, as a coordinate. And let's actually label these. This is the graph y equals 6 minus x. This is the graph of y equals 2x plus 9. Now we just need the straight lines. We have a horizontal and a vertical. This is the graph y equals 3, or this is the equation y equals 3. If you don't know, guys, what the equation y equals 3 looks like on a graph, I'm going to show you now. So recall, guys, that when y equals 0, we were on the x-axis, yeah? So all you do for y equals 3 is you just go up by 1, 2, 3, and it's a straight line with a y-intercept of, you guessed it, 3, okay? So it goes like that. all it is. And so that's the line y equals 3, okay? The reason for that is because at every single point across this straight line, this horizontal line, the y coordinate is 3. If you're here, let's say that this is like, I don't know, minus 10 or something, x is minus 10, your y point is still 3. If you're over here, this point here is 3. If you're over here, this might be 6, 3. It's always going to be 3, so that's the line y equals 3. Likewise, we want the line now x equals 0. The line x equals 0, just like how the y-axis, or just like how the x-axis is the line y equals 0, the line x equals 0 is just the y-axis. Okay? So on the y-axis, x is always 0, if you think about it. So that must be the line x equals 0. And right now, I'm just pretending that I'm doing something by going over the line that I've already gone over because it's just the y-axis. So this is actually the line x equals 0, okay? Now, guys, we need to put the inequalities back in because we've plotted the equalses, but we need the inequalities. So we want when y is less than 6 minus x. So remember, this line here is the line y equals 6 minus x. So when are we less than that line? Well, we're literally less than that line everywhere below this line. So not above it, but below it, we're good. But it also needs to satisfy, where is it? Y is less than 2x plus 9. This is the line of 2x plus 9. We need to be below it. So we need to be below this and below this. And it turns out that essentially, if you imagine this is a triangle with a point at the top there, we have to be sort of below in this triangle area. We can't be up here and we can't be up here because of the restrictions that we've got, because of the inequalities. Now we need to see when y is greater than 3. Okay, well, y is greater than 3 above the line y equals 3. So it's all the stuff going up. But guys, we're restricted a little bit because we can't come over here, we can't come over here, so we need to be sort of going up above. So right now, using the 3 conditions, we've got a triangle with these 3 points. 1, 2, 3. That's the area, that's the region. But there's one more thing. X needs to be greater than 0. If x is greater than 0, guys, this is the line x equals 0. For x to be greater than 0, we're onto the right-hand side. When x is positive, the right-hand side, which means actually we're bounded by this triangle. Rub these points off. It doesn't look very good, but it's essentially this triangle here that is the answer. If you don't believe me, you can just look at it and check. Are we less than 6 minus x? Yes. Are we greater than x equals 0? Yes. Are we less than 2x plus 9? Yes. Are we greater than y equals 3? Yes. That's the region. That's the only region that satisfies all of those conditions. Now there's one more thing again, guys. All of these are not less than or greater than or equal to's. They are less than or greater thans, which means the lines must all be dotted or dashed. So I won't actually use the rag, I'll just use my finger because it's such a small area. We essentially end up with the same region, but we just dash the lines like that. That is the final answer. So guys, if you really, really want to have more of this stuff, have more of me doing these videos, please let me know in the comments below. But otherwise, we will be moving on. Again, don't worry too much about the straight line stuff because there is an entire topic on straight lines that we will get to, and we will go through it very thoroughly, I hope, and hopefully it will be a lot more sense. And what you can do is if you watch those videos when they are released, hopefully fairly soon, you can come back to these videos and hopefully all the straight line stuff will make sense with that sort of knowledge retroactively, okay? It's just a bit of a weird, strange order that they teach this whole A-level thing in, but you know, who am I to judge? Anyways, guys, thanks so much for watching. Please share, like, subscribe, tell your friends all about how you shaded some regions on an inequality graph, and I will see you guys in the next video.